Welcome everybody to Calculus BC. In today's episode, we're going to be discussing some homework questions that I was unable to do in class, and so we will go ahead and clarify those questions for us. So in number 19, they're asking us to use differentiation to find a power series for this expression right here. Well, what I'm going to do is I'm actually going to go ahead and go back to something that I do know. I know that f of x is equal to 1 over 1 plus x. And if I was to expand him out as a power series, first off, I can go ahead and see him as 1 plus x to the negative 1. And that's going to be, if I was to expand him out as a power series, he would look like this. He would be 1 minus x plus x squared minus x cubed plus x to the fourth minus x to the fifth plus dot dot dot. And so from here, it's just an alternated version of the normal power series that we're used to. Now what I'm going to do on either side is I'm actually going to derive either side. So if I derive each side here, what I get is I end up getting negative 1 plus x to the negative 2, which is really negative 1 over 1 plus x squared, which is almost what they have me getting. But on the other side, what I'm going to get is the constant's going to go away. I'm going to have negative 1 plus 2x minus 3x squared plus 4x cubed minus 5x to the fourth, dot, 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 dot. So here's the thing. I almost have what they want. I don't have what they want. So what I'm going to do to get what they want is I'm going to multiply both sides by negative 1, giving me 1 over 1 plus x squared equaling. All the signs here are going to change. Remember, because I'm multiplying both sides by negative 1. It's just like an integrated 1, right? What I do to one side, I got to do to the other. So now I'm going to do 1 minus 2x plus 3x squared minus 4x cubed plus 5x to the fourth, blah, blah, blah. Okay, so I have just completed A. I have now done the power series for 1 over 1 plus x squared. Hopefully that makes sense. In B, they're asking me to use part A to find a power series for this thing. So what they want from me is 1 over 1 plus x cubed. Well, I don't really have that right now, but I do have this guy. I do have my answer from part A. So what I'm going to do is I'm going to write down my answer from part A. I'm going to say 1 over 1 plus x squared is really 1 plus x to the negative 2, which is really 1 minus 2x plus 3x squared minus 4x cubed plus 5x to the fourth, blah, blah, blah. Well, again, I'm just going to go and derive this thing out. So I'm going to derive both sides. What I get is I get negative 2 parentheses 1 plus x to the negative 3, which is really negative 2 over 1 plus x cubed. And again, I know that's not what I want, but if I just derive both sides, I'm going to get negative 2 plus, and I'm not going to multiply those guys. This is where the crisis kind of happened. 3 times 2x minus 4 times 3x squared plus 5 times 4x cubed, and down the chain we go. I'm going to go and multiply both sides by negative 1/2. That way I can get the version that they want. Scroll over to the right here a little bit. That's going to be 1 over 1 plus x cubed equaling negative 1/2. Negative 1/2 times negative 2 plus 3 times 2x minus 4 times 3x squared plus 5 times 4x cubed, blah, blah, blah. I actually am going to just multiply the negative in and keep the 1/2 on the outside. So that's really going to be 1/2 times 2 plus 3 times 2x minus 4 times 3x squared plus 5 times 4x cubed, blah, blah, blah. Now I'm going to call them 2 times 1 here because I want to establish this pattern here. The series generator for this thing is going to be from n equals 0 to infinity with a 1/2 on the outside. And the way I'm going to get these terms here is I'm going to call them n plus 2 times n plus 1, right? Because if n equals 0, that's how I get these two guys. Notice how they're always sequentially down. So again, if n equaled 1, I would get 1 plus 2 is 3, 1 plus 2, 1 plus, oh, that's not supposed to be that. That's supposed to be an n plus 1. N plus 1. So hopefully that kind of makes sense. The x's, this is x to the 0, x to the 1, x to the 2, so that's x to the n. And there's an alternator out in front. So this is your series generator for number 19b. And then for 19c, it's actually pretty easy. X squared over 1 plus x cubed is really the same series we had before, with a 1/2 on the outside, but now he's being multiplied by x squared. So that guy can just bust in and multiply in by that guy. So you get 1/2, n equals 0 to infinity, n plus 1, n plus 2, x to the n plus 2 times negative 1 to the n. Hopefully that makes a lot more sense. I will move on to the next problem. Give me a second. Okay, in this problem here, they want me to find a power series representation for ln of 5 minus x. Now, in this particular situation, what I'm going to do first is I always kind of want to revert back to what I know. I know that f prime of x is equal to 1 over 5 minus x times negative 1 for chain rule, which is almost like something that I know, right? If I factored out that 5, I could call him 1 over 1 minus x over 5 like that, and then power series this guy. Well, what that power series is going to be is, remember, the power series representation for this thing is going to be 1 plus x over 5 plus x squared over 5 squared. Remember, x over 5 replaces all the x's, plus x cubed over 5 cubed, plus x to the 4th over 5 to the 4th, plus dot, dot, dot. And don't forget, there's that negative 1/5 on the outside. And now from here, if I was to integrate this thing back in, right, because I'm trying to get to ln of x, if I was to integrate this thing, I would get x plus x squared over 2 times 5, plus x cubed over 3 times 5 squared, plus x to the 4th over 4 times 5 cubed, and blah, 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 right? So I'm going to go and create a sequence generator for this thing. So it's really negative 1/5 times the sum from n equals 0 to infinity. Looks like my x's are going up by x to the n plus 1 looks like. Over, if this is 1, this is really n plus 1. The 5 seems to be going, this is n equals 1, n equals 2, n equals 3, so it's 5 to the n, except for a plus c. Because remember, when we integrate on an indefinite integral, we have to take into account that plus c, right? So from here, remember, this is supposed to equal ln of 5 minus x, right? And remember, the power series that we've been doing, power series are centered at 0, right? So if I center this thing at 0, that means that x has to equal 0, which means if I let x equals 0 on this, that means I get ln of 5, which is what c is going to be. So I've got c from n equals 0 to infinity, right? And actually, it makes sense because in this case, if I let x equal 0, all I have is 0 over 1, which is 0, right? So I would have 0, this would be 0 over 1 plus c, which means I've got ln of 5. So from here, go ahead and just plug in ln of 5 as your c. So x to the n plus 1 over n plus 1 times 5 to the n plus ln of 5. And that will wrap up your problem number 21. So hopefully that makes sense. And as always, please leave comments or questions in the comments area. I will see you all in the next episode.